Thank you for joining us today. We have another great show and an amazing guest. Today, we are looking at how space-based power can be used to provide sustainable energy for long duration missions on the moon. Our guest today has spent years developing energy infrastructure to advance lunar programs. Welcome to the Tech and Space Leaders Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Paolo Pino. He is the co-founder and CTO of Volta Space Technologies. Welcome to the show, Paolo.
Thank you, Lisa. Hello, everyone. Thank you for having me.
Absolutely. Why don't we start by having you give a little bit of background on yourself and Volta Space?
Yeah, for sure. Thank you. Well, I am the technical co-founder. I started this after a background in space systems engineering, looking into space exploration missions and architectures. And I joined the International Space University, the course on commercial space studies. And that's where I met my co-founder, Justin Zitkin. And CEO of the company. We started this about 6 years ago, almost now, and we had a lot of fun ever since trying to build a energy grid for the moon.
Wow, amazing. So, what was the core problem that you were really looking to solve when you guys founded this company?
When we started at the beginning, we thought, okay, now that we've seen this great wave of improvements and capabilities for launch and transport in space, the next big enabler has to be energy. If we manage to create energy services in space, then we're going to make so many activities a lot easier and more affordable and scalable. And so we started with that sort of question in mind. And as we engaged with satellite operators and developers, we were learning more and more about how that was uh, a big problem for lunar exploration missions among the various ones. So on the moon you have this very long lunar night that kills every mission, almost any mission that goes there, which is obviously not sustainable over the long term. And so the idea is, okay, let's try to solve this by providing um, affordable energy to those missions such that they can go past this lunar night and keep the operations going for a lot longer and build that foundational sort of infrastructure and technology, scientific knowledge that we need in order to stay on the moon sustainably and permanently.
Great. So, can you talk a little bit about what you are developing and how that is making it, I guess, more affordable and scalable to support these lunar missions?
Of course. So let's maybe look at how it's done today, or what's the state of the art, what's possible. Um, every time you go to space, you're going to bring with you some payload, and you have to make compromises depending on the resources you want to have available. You're going to have to give up some of that payload mass in order to bring on additional battery mass, for instance, and have more power or more energy. And if you wanted to apply the same reasoning to a lunar mission, that will quickly become pretty much prohibitive. You will end up having to have hundreds of kilograms of batteries if you wanted to have enough energy to survive that lunar night that we're addressing with a different solution. And so right now it's just very hard to do it with state of the art systems. The approach we're taking is to decouple the energy source or the energy storage um, from the actual assets and place it somewhere else where it is cheaper and easier to get that energy. And from there, we just transfer it to that asset. So we basically build lasers that are able to operate in extreme space environments at high power levels. And then we can point very accurately to the users that require energy. So we point a laser beam that's living in satellite in lunar orbit, and that laser beam reaches a tiny little photovoltaic receiver that's installed on the lunar probe. And at that point, the laser energy gets converted into heat and electricity. And so now you get the energy from outside. You don't need to get that massive battery pack with you. and you free up, a lot more payload space potentially, as well as the ability, most importantly, to stick around for longer.
Wow, that's amazing. Okay, so are these, I guess, power sources in orbit, in lunar orbit, or are they on the lunar surface? How does this operate?
Right. So the vision is to have a constellation of power beaming satellite in orbit around the moon. Once you are in orbit, obviously you're going to fly over many regions, so you can distribute that energy to multiple sites, and this makes it very scalable. And also, the cost to establish something in lunar orbit is lower than it is to go on the lunar surface. So we can essentially, spend less to deploy that energy infrastructure and pass those savings on to our customers and bring the cost of energy down for everybody. So that is the vision there, but there's obviously the possibility to bring some of those elements on the surface as well. And so if you want to transfer energy from point A to point B across the lunar surface, you can do it with lasers as well. There are obviously many alternatives like cables, for instance, but there's a point where the sort of the amount of mass that you need in order to transfer X amounts of watts over Y distance, is lower if you use lasers rather than cables. And so there are use cases for surface-to-surface energy transmission as well.
Wow, amazing. Can you talk a little bit about the engineering breakthroughs that kind of make this all work?
Yeah, probably there are several. Okay, we have to build an end-to-end energy transmission stack, and you have the laser source, you have a pointing system that takes where the laser goes, and then you have a receiver, a laser receiver on the other side that is the piece of hardware that the user can integrate in order to convert laser back into electricity and heat. So you need breakthroughs across this chain. But the very first one is the laser source. In order to deliver meaningful amount of energy to users, you need to be able to operate a laser at very high power levels, which entails high temperatures. And you have to do that in an extreme radiation environment in space. And there was no laser that was able to do that back in the early days. So we had to start with that, building a laser that was able to withstand those extreme radiation levels, extreme temperatures, the swings of temperatures. Um, and that was the first breakthrough that Volta came up with. And then obviously you have to be very good at pointing, and so you need a very sophisticated pointing system. And the receiver as well, something that just didn't exist, at least with the ability to operate on the lunar night and to be very efficient in the conversion of laser energy into electricity and heat. So that is where we also devoted a lot of thinking and building and research resources.
Wow, amazing. Okay, so I understand that you actually have a launch coming up toward the end of this year. What are you going to do during this particular mission?
Yeah, so this mission is going to deliver a small laser power receiver on the lunar surface. We're gonna do this with Firefly. We're gonna be part of Blue Ghost Mission 2, and the payload essentially comprises this sort of small version of our receiver, which we call LightPort, which is going to be installed on the top deck of this lander, reach the lunar surface, and demonstrate that it's able to operate in the lunar environment across the lunar day, um, and to generate energy and electricity as it gets illuminated by the sun. There will be no laser yet as part of this mission, but the wavelength of our laser is just contained in the solar spectrum. So our receiver can still generate energy if it's illuminated by the sun, and we're going to use that to characterize its behavior in the lunar environment across several days.
Wow, that is really exciting. So this is your first actual kind of proof of concept on the
Mhm.
lunar surface. What, this is really exciting.
Yeah.
Yeah. So how do you actually envision this in the longer term in terms of distribution for the lunar missions actually working for maybe commercial, scientific, other requirements?
Yeah, that's a great question. There are, if you will, many steps, many layers. There's the long-term view vision is that We'll have several satellites orbiting the moon and providing a very predictable, clear, transparent coverage of the moon, such that any mission planner, any instrument builder and designer knows how much energy they will be able to receive depending on their chosen landing sites. And they can plan the mission around that, just like they do right now, knowing the illumination pattern of the sun or the coverage from telecommunication ground stations and relay satellites, just adding essentially that sort of infrastructure you can be confident that it's going to be there, that it's going to help your mission, and it's just going to be part of how you plan it. And so that requires having a certain number of satellites operating and the ability to make that energy available and accessible to customers. There are many steps to get there, obviously. So we're going to start with the first satellite. We have a program going on right now, which is called Lepton, through Volta Space US, that is exactly building that first unit. It's going to be deployed around the moon for a first demonstration mission. That unit is going to be there to deliver energy to the early adopters. And at the beginning, it doesn't have to be something that an entire mission relies upon. It can just be a bonus. You do your mission, and you just let it warm it up towards the end once all your objectives have been accomplished. And you'll get that extra heat, that extra loss. That might take you some days or some hours into a lunar night, and perhaps even on the other side of it. And that's going to become more and more certain and clear and predictable as we add additional nodes to this first one and create a constellation.
Wow, amazing. So, is this a technology that we could potentially use on Earth?
It is. Volta has indeed a product and the ability to use this technology on terrestrial markets as well. There are sort of different flavors of it that we can make use of, but certainly there have been instances also by other organizations um, um, where this technology has been used to charge robotic assets, for instance, drones that fly or that move on the ground. So yes, there's definitely the possibility to use it on Earth as well.
Wow, fascinating. Is that something that you've tested or looked at on your end at all?
Yeah, Volta is on contract with NATO to use this technology to charge some robotic assets, and again, we do it with a different flavor of it, but the core idea there is that you use the laser to deliver energy to those assets. We've demonstrated the ability to power up a little drone um, for several hours with at minus 40. And the reason why I point out this low temperatures is that drones on Earth have similar problems than lunar probes, meaning that they carry a battery to accomplish their operations, but the cold and the low temperatures they just kill that battery capacity. They make it harder for those drones to operate for long enough. If you have a battery that gives you 30 minutes of operations, but it's now minus 20, you only get 5 minutes of operation. So we demonstrated that we could power up operations for many hours at minus 40 using this kind of technology. And so that's what we're doing for terrestrial use cases here.
Wow, that's really exciting. That is very, very cool. So I understand that you may also have a second launch that's already scheduled as well. What will you be doing on that mission? Do you know? And what are the outcomes that you're hoping to get out of the second mission then?
Yeah, so second mission is happening next year. It's going to be done in partnership with our friends at D Cube. The mission is called Arrakis. The goal of this mission is going to host multiple power beaming payloads, including Voltas, and we will be um, um, we will beam power across about 10 meters from the laser source to our receiver, where the receiver is essentially installed on a deployable structure that extends, several meters away from the main payload bay. And so this is going to allow us to demonstrate also our laser element at very high power levels and to run power transmission operations over and over to build more areas across the system. And we're going to use the energy of the receiver to power up a little computer in space. There's going to be a sort of immediate use case that we're going to validate in that mission.
Oh, that is really, really cool. Okay, so what's your perspective on the whole data centers in space? You've kind of piqued my interest now.
Yeah, yeah. Wow, that's a huge question. I think there's still a lot to find out. I think it's a very exciting time to see how who's working on it addresses the technical challenges and to see how the use cases and sort of the value proposition for the market shape up. I don't have, a strong opinion on that. And I think there's a lot yet to be seen and learned, but it's overall very exciting. And there could be scenarios where delivering power from a sort of third party asset makes operations easier for those orbital data centers.
Right, right. Okay, so we've talked about lunar missions, we've talked about potentially using this technology on Earth, but we haven't talked about using it in LEO. Is that something that we could potentially see as well?
Yes, for sure. Obviously, power is a constraint for any system. Any robotic system has to deal with the limitations of what the solar panels can give you or the battery, etc. So there are indeed use cases where beam power can support LEO missions for a variety of applications, including maybe supporting a sort of contingency scenario where you have a fault in your system and you require that extra power to continue your nominal operations, as well as extending the lifetime. You're going to have to deal with a certain degradation profile of your power generation ability. And so as that, keeps decreasing due to just the natural decay of your systems, then maybe you can add up an extra sort of power boost and keep it at the near the sort of beginning of life type of performance values. But also electric propulsion is another interesting one. You want to maneuverability and mobility and logistics in space. It's growing, and you want to have the ability to maneuver without regret or being able to perform those high power operations that bring you elsewhere. So those are some very exciting use cases for this technology in LEO.
Excellent. Wow. Okay. When you look at kind of that long-term vision that you talked about and then meeting near-term goals, how do you sort of balance those two things?
Yeah, yeah, that's a great question. I think you work backwards from that long-term vision, and you try to define those milestones and steps that get you closer to that. And it goes all the way back to identifying what are those sort of main risks that you have to retire. And this is something that Volta has done successfully in the last few years, building those breakthroughs and showing that a high power laser can operate in space. And then you go and you perform your mission and you validate that element of the architecture and you build incrementally until you get there. And so you do that, obviously trying to engage as closely as possible with all the stakeholders and the missions you're trying to support and the customers and the space agencies. So um, it's a long way until you can have that constellation that just people don't think about, and it's just there and they know it. I want this to be given for granted almost. But there are steps that can clearly be identified along the way that already bring value to those stakeholders. And so that's the other dimension. Not only you want to identify, what are the technical milestones to be achieved along the way, but also how can you create value for your users and stakeholders as you do that. And so you have the first node that already has submissions with an extra lifetime extension. And then you have the first two, maybe or three already making several assets surviving the lunar night, and you can go there very early when all this, CLIPS missions and new programs planned for the next 2 or 3 years and so on are already being launched to the moon. And so you create that immediate use case and opportunity to test things out and to see how you can infuse this capability into the broader picture.
Right, right. One of the things that you've talked a little bit about are some of the other organizations that you're partnering with to make some of these missions possible. How important are those partnerships to basically accelerating your program.
Sure, they're obviously very important. We're very happy to be partnering with Firefly for this mission. Volta has also um, a strategic partnership agreement with iSpace US to examine survive the night capabilities. And obviously, we work a lot with the space agencies. We're under contract with the Canadian Space Agency and with the European Space Agency and NASA. So partnerships, stretch across the whole landscape of all the actors that are involved in lunar exploration, and the commercial actors, are that fundamental contributor to the missions and the adoption of the service and the demonstration of the service. And obviously, you have the space agencies that provide that sort of broader architecture and long-term view that opens up, the possibility for organizations like Volta to really create something long-lasting and enabling for all this sort of government-driven goals.
Absolutely. Okay, well, I want to thank you so much for making the time to be here today to talk about the amazing work that Volta Space Technologies is doing. If someone wanted to learn more about Volta, what should they do?
They can reach out. They can look at our website and LinkedIn page. They can reach out to me directly. I'm always happy to engage with other people in the industry. And yeah, it's all very exciting. Thanks a lot, Lisa, for having me.
Absolutely, our pleasure. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.